filtration. You have a filter paper, right? It's used to separate a suspension. So the solid will be retained in the filter paper. The solvent will leak out in the beaker or the container in it. So the filter paper have pores that will not allow an undissolved substance to pass through. So the particles of a suspension will be too large to pass through the filter paper. Right, so it's just basically a paper you fold it, put it into a funnel, and you just pour the suspension in it, and the solid component of the suspension will remain on the filter paper. The solvent, no, not the solvent, but the liquid aspect will pass through. Correct. Evaporation. Now this is used to separate solid from a solution. So the crystals, if you leave the solution to evaporate, the water particles will leave, or the solvent particles will leave the surface slowly, and as the crystal will reach the solubility point, they will start to crystallize out of solution. Because remember that, as I put the definition for solubility on the board before, it's mass of solute that will be dissolved in 100 grams of solvent at a particular temperature. Right? So if you have room temperature, we have a solution. As the volume of the solvent decreases, it will no longer be able to dissolve all the solute. So it will gradually precipitate out of solution. Right? Crystallization is a similar process in which crystals will form. Alright? The evaporation aspect is that sometimes with this one we tend to apply heat. The crystallization we just leave it at room temperature. Both of them similar, very similar. Right? One is just faster than the next. While crystallization tends to be used to like the solid, which probably are heat sensitive, would have to go through a slow process, or if they have water of crystallization as well. So like if you want to form copper sulfate 5 water, hydrated copper sulfate crystal, which are blue, we wouldn't use evaporation technique. We'd actually have to use crystallization because it still requires some amount of water in the crystal. Simple distillation is normally used to separate a solution in which you have a large boiling point between the solute and the solvents. For example, like a sodium chloride solution, we can use simple distillation because the boiling point of water is very, very low when compared to the boiling point of sodium chloride. Fractional distillation, we use it to separate a solution again, which have the solute and the solvent have close boiling points. Like ethanol and water, the boiling point for ethanol will be 78, boiling point for water is 100. Simple distillation will not be able to separate ethanol from water, so we have to use fractional distillation. The separating funnel is used to separate immiscible liquids, so like oil and water, which they know, so it's like a color type of thing, they're not miscible, period. So you just sit on each other and you can just separate them. Paper chromatography is used to separate like the different components of like dye, like for example like ink. So the filter paper, and you have the solvent moving up the filter paper, but the solute will have different solubility or affinity for the solvent, and different affinity for the filter paper, and different solubility in the solvent, right? Here now the filter paper here. So also, if like for example, you have a saturation solution and the solid is some of the solid undissolved, you can remove that solid as well. But in a sense, if I have undissolved particles in a solution, it's not really, that aspect is not classified as a solution, right? And then here is the filtrate. This is the liquid. And then this is fun. Alright, so next is evaporation. So heat stable solute. this is a heat stable solute or crystals are unhydrated. Crystals are unhydrated. The third one is crystallization. Can you erase this, right? So instead of putting the dish, round bottom dish and a beaker, boiling water, we just leave it on the bench, right? Room temperature. Then now I'll put a filter paper on top to prevent dust or any impurities from going inside. Because it's going to be a slow process, crystallization, you probably leave it some crystal takes like months to be formed, while some will form like a day or two. But in general, some crystals will take even like 2-3 months. That's how slow some crystals break, vary from like a day to months. Evaporating dish. Remember that the filter paper won't prevent the solvent from evaporating, because normally the solvent can pass through filter paper, liquid will pass through. So remember, this is done at room temperature. Crystallization. Next we move on to simple distillation. Finish?
Yes, yeah.
You can draw this from any book. Good diagrams, practice. Because you most likely will be required to draw it in the exam. Right? So solution here, example NaClAq, right? Now, as I said before, this use a solution which is solute of a very higher boiling point than the solvent, right? So in this case, for example, sodium chloride solution, water will be the solvent, sodium chloride is the solute. So what we're going to do here is that after we apply the heat to the distillating flask, the water is going to boil. The water vapor, I'm just saying water here using because this is the example. The water vapor in this, but it could be any solution in which the solvent is the liquid, right? So in this case, the solvent, which is water, is going to evaporate and go into the condenser. The condenser is basically an apparatus which has it has this tubing which is going to go from this flask straight through. And what's that was paper. No, a different color. Normally you should have like different colors. Let me get the drift. Like this was like a different color from this. Alright? However, the black here would be like the original dye. Fastest movement. Yes, as I said before, like chlorophyll, if you should put chlorophyll or put like a ink, black ink here, you put a solvent that can dissolve it. As you move, like different solute would move at different rate and they will just separate on the filter paper. Alright? So normally how this works is that you put a piece of filter paper in a solvent, it will just gradually move up the paper. Alright, and then that will cause separation.